Hello again, and thank you everyone for joining us for today's Dr. Sound Academy. Thanks for taking some time out of your busy days to get a better understanding of the SIP protocol and how it works. My name is Nelson. I'm in the marketing department. Today we will have Faisal Magul presenting. He's the product development technician in our tech department and very knowledgeable in this area. So I'll pass it over to Faisal and enjoy the webinar. Thank you.
Thank you so much. My name is Faisal Mughal, and I am working with the product support and product development side as a technician. And before I started the session, so I just like to introduce myself a little bit small brief. That is actually how I deploy the SIP environment into a different solution. So I work with the SIP deployment in the Asia Pacific and North America, and most of the network side, I work with the major network provider like Verizon, Dell, IBM, Singtel, China Telecom, TechNet. And especially on the service provider side, I work with the CGI, IBM, and Bell. The solution that is actually the SIP which I deploy most of the time is the Microsoft Skype for Businesses. Intel, of course, is the key hardware provider. Cisco, Polycom, Nortel, Ectel, Alcatel. And some are the product like Polycom, Crestron, Lifesize, Tandberg. So these are the solutions that I had the big, the background on it, complex, successfully deploy the solution, and still those solutions are working. So before we started, so now we actually move to our actual session, the SIP. Thanks a lot that you're joining this session. So today our topic is actually the SIP communication and how it will work and how it works. So today agenda is for our SIP is we'll discuss about it. What is the SIP protocol? How does it work in a voice over IP call scenario? And what type of a TO product we are provided in the SIP environment. So first of all, before we started, we just need to clarify ourselves what is a SIP and what is a voice over IP. So these are the two technical terms is always we are using it, and there is a need to understand what's the difference between the voice over IP and SIP. If you look into a SIP and voice over IP, so voice over IP you can say is the big umbrella of a internet voice protocol, and underneath voice over internet protocol, the SIP is just a small portion that actually feed the voice over IP umbrella. So SIP is actually, if you say, is the just a signaling protocol which actually make it happen or which make it possible the voice over IP in the signaling world. So and most of the time, this is actually people often use the SIP and voice interchangeably. Thought that they are the same kind of the lingos, or they are the same kind of a vocabulary that actually we use, but they are completely two different kind of a the system or technology. Voice over IP is the big umbrella, and the SIP is sitting just underneath the voice over IP, and that's how the voice over IP broad term can cover. The SIP is actually is part of a group that is actually can accommodate into the voice over IP. So that's the big difference between voice over IP. Second thing is actually why SIP? Why don't we actually talk about the HT23, the other technology that we have it right now in the world? So why only the SIP? It's a simple, easy answer. SIP is when we are going a little bit more further into a deep dive into a slide, so you will see that's actually how SIP is flexible. Why not the other solution on a voice over IP is not flexible? So first of all, SIP is offer is an open standard which make the more reasonable for a lot of vendors to build the solution in the SIP Second is the SIP is itself is the open standard and itself is a very flexible. So I remember that is actually when the SIP is introduced. So you have a lot of RFCs. RFCs is actually open standards, which is actually when you are talk about the SIP open standard. So on the protocol side, these are the RFCs. So each vendors they go and pick the RFC and they build the solution as per the RFC. The SIP is introduced by the 3261, 62, 63. So these are the RFC that build up is open standard and how the SIP is evolved slowly. And you can see that's actually as the open standard actually, if you see 32, 61, 62, so you can say this is the SIP version 1, SIP version 2, SIP version 3. So these evolvement is actually is give you more features. So you can see that's actually open standard and is flexible to adopt a new feature. So this is a big cost saving. So cost is also a big main driving decisions to initiate the any project. So that's why the SIP is very acceptable into the in today's world, and because of its flexibility and plus the cost-effective solution. So that's the number one why we use the SIP. Why not the other product that we can use it. Second thing is actually the SIP, as we are discussing the older architecture and the newer architecture, which is SIP. So you can see that actually you all remember when we actually in old days, this is actually we dial the number, we pick up the phone, which is actually run onto a 50 volt system, and that 50 volt system is actually give you a ringer and plus is actually call signaling. So you can see is actually various technologies involved when you are actually engaging this technology. So you see this is ISDN, and plus is actually when it's hit to a CO, and CO is actually doing the packet the switching, which is SS7, and at the end, then we actually ended into the soft switch, which actually convert your SIP environment. So the reason to show you this picture is give you the involvement of all the technology and what are the limitations in those architectures and what are the why we choose the SIP. So if you see this is actually in this architecture, this is actually 50 volt ring, give you the ringer to a phone, and then you actually go to a tandem switch, which is your CO, and in this one PSTN you can tell is a PSTN, or you can tell is a so in this one is actually if you are increasing the any line, so is fixed, and if you're increasing the line, so you have physically initiate and put physically the lines. So this is like a very challenging, and is actually cost a lot of money to implement the real circuit. This is where the limitation for this kind of architecture, if you see SS7 or the ISDN, that is actually cause a big burden on our pocket. This is where we actually come up with the another solution, which is like a SIP. So SIP is actually is just like a based on the internet, and then is actually if you have a bandwidth, so you can accommodate as many line you wanted. Is totally depend on your network, and you don't need it the hard kind of a physical infrastructure that is actually require your huge amount of money involvement. So adding a feature in the old architecture is just like a just a nightmare, but as compared to SIP, it's easy, deployable. So that's why it's actually the technology-wise, the solutions cut it down to the everybody can afford it, that solution. So that's where the the SIP is the de facto technology now and upcoming days. I go over again what the SIP is. SIP is actually is just like signaling protocol, as I explained you. In the PSTN world, in the old public telephone switching, we use the ISDNs, and in the CO, SS7. So same kind of a idea that is actually for signaling we are using for phone telephony is the SIP. SIP not only do the phone signaling, it has to do more than that one, and is actually not only enable the voice, is also do the messaging, video and other type of applications like precedence. If you want to do the status location, that is okay, this is where I am and this is not where I'm not. So this is also you can do with the SIP environment. So it's actually it's kind of a protocol that is actually is give you the idea that is actually is a signaling, but it's not involving itself into encoding and transmitting data, which is entirely different kind of the protocol involved in it. So if you see what I'm talking about, that is actually SIP itself is sitting onto a top of a transport layer. So if you recall yourself from a network perspective, so you have a 9 layers of the OSI model, and you have the application layer, transport layer, network layer, and then you have a data network layer. So SIP is sitting onto an application layer. So this is if when is sitting onto the application layer. So the way that the communicated SIP is regardless of what transport layer, UDP or TCP, it doesn't care. If you look the architecture of the SIP protocol, so you can see that actually SIP sit on top of a TCP or UDP or SCTP. So TCP, UDP, and SCTP, these are the transport layer. SCTP is the old IBM protocol, which is actually used for the streaming of the streaming of a protocol, which is like a link-based, link-oriented kind of the protocol, which actually connected the one stream to another stream as compared to TCP, which is like the connection-oriented protocol. So you can see SIP is sitting onto a top of which you heard the name of a FTP, HT23, RLog, and Telnet. As you see, this HT23 is another this signaling architecture, which is giant competitor for a SIP. But the reason is actually we're not using anymore the HT23. The reason is actually because of is a monolithic kind of architecture, where the SIP is a very modular kind of architecture, where you can, if you want to ingest the new kind of a feature, you can add the new feature in a SIP, where the HT23, which is used for the voice, dedicated only for a voice, and not the newer version, the newer form of a HT20, you can easily add the but because of it's a monolithic, you cannot add the feature very easily as compared to SIP. And the product line is also vendor specific. That is actually, if you wanted to add any other feature, that's not actually like it, a new feature. So that's why the SIP is the ideal platform for any device that is actually SIP oriented. Second is actually, if you look for the SIP environment, SIP network architecture, so SIP is actually comprised onto the couple of servers. Sometimes these servers are actually individually coexist, or they are coexist into a one server. So redirect server, a registrar location server, a proxy server, and ultimately all those ones is connected to a user agent, which actually ultimately go and connect with the PSTN gateway, which is like a public switched network, which actually give you the telephone number, which we in the telephonic world we call as a DID number, which we known as a direct inward dialing. Most of the time, this is our ultimate goal, but the SIP can do more than that one. So as we discussed the SIP architecture, so the SIP architecture is like a proxy server. So proxy server is taking all the call signaling between the client and server. So client is your user agent, and the server where your PBX or your SIP server is sitting in. So it's taking all the signaling behalf of a this one. So that is actually is the type of a server, the proxy. Redirect is actually something that's actually if you are talking to another user agent, and between these two user agent, you actually don't want to expose your your internal IP address. So this is where the redirect server can comes, and then it directly call or indirectly call to a server. So that way is not expose your information. A registrar is this is where all the your user agent are actually registered. So it's just like a register or ledger that is actually keep updated itself, and anybody who has the extension in this registrar or have a information or have a dial plan that is actually rerouted or make a call to signal make a call to a signal user agent. But that is actually is allow the system to request or execute them or send replies. So this is the normal architecture. So you can see is actually how the communication of a SIP protocol. So SIP protocol is actually it's very if you see in the UDP style, so UDP or TCP, they are talking into a port, but into a SIP environment, the way that is actually the communication going between client and server, so is kind of a clear text base. Or in a clear text base is actually the way that is actually communicated is into a request and the response. So request and response is actually kind of a is a kind of a not the request, but the response is actually is come back as a numerical way. So for example, sometime in a response, you can see that is actually these are the provisional kind of a response. So you see the 1XS or 100 or 122 or 100. So these are the responses which is actually provisional based. Okay, I'm provisioning it. Or sometime is actually if the call is successful or call is actually accepted from the other user agent, so response will be come back into a 2XS. Or if it is the redirect kind of a response, then it is comes into a 3XS and so on. And if there is a request failure, so you can see right away 4XS, which is like a 483 or 487. So this response kind of give you the hints of, okay, what is if this is a response I'm getting it, so must be there is the issue with my the user agent at somewhere. So these are the response and the request client and server session when is actually initiated from the SIP environment. So you can see is actually this is the very good example. It taken by the the two of a user agent. One user agent is user A, and the other one is sitting on to a SIP A. So you can say that you can see that is actually the it's requesting to a gateway. Set up a call, and then the gateway on behalf of a the user agent is sending a request for the is sending a request which is number 2 to the user agent number B, and then is actually you get the response. So as I told you in previously that the response is coming up with the number. So you can see the numeric number in a 3-digit 100. So it means trying it, and then it send a ringtone 180. So that's another ringtone, and then is actually you receive the alerting, which is like a sending a request, and then is actually you get the response okay, then request connect okay, and then once the sending a request for acknowledge, and you can see that is actually so this is like you can see is the whole kind of a signaling, and once the signaling is done, so you can see that is actually this is the media open between the SIP environment, between the user A and the user B. So this is a very important, that is actually that the RTP channel. So signaling is happening from 1 to 10, and then the two-way communication build onto RTP. So most of the time when we are actually call and we say, oh, my phone ring, but I cannot talk to a person, always understand that is actually the SIP is just a signaling, and there is the lot of other involvement of a protocol, and which is like a RTP protocol. So this is actually the media where the voice is carried over. This is your voice path, which we call the RTP. So that is actually something different than the SIP itself. So this is if your firewall is blocking off, so then definitely it is, you need to look into it. And once the phone says, okay, I'm hanging up, I don't need to communicate more. The user B is sending a bye and then is disconnected. And once it's disconnected, release the channel. And the release the channel is actually, it says, yeah, okay, release it, okay, and then the signal is completely done. So that's the brief about it. The how the whole SIP is actually from a signaling point of view, and how the media itself, which is like your voice over IP, which is like the RTP protocol it created itself. This is the another call relationship of the component. In previous one, you can see this is actually we involve the gateway into IP network. So this is something that is actually sitting in a campus environment or something which is like a global environment. That is actually I have a different locations, and it goes through the gateway. Now this is something that is actually you coming out from the internet side of it. So sometimes is actually your proxy is cloud-based environment, and in that cloud-based environment PSIP, so you go through the proxy server. Proxy is just like hiding your public network and your internal network from your campus LAN, which means that is actually you don't want it to expose your internal information or user ID. For example, your user ID is most of the time follow the E164. So E164, it is the extensions that is actually it is a standard ITU standard that is actually 5-digit number or 6-digit number, and then when it's hit the LAN, then it's actually proxy is calling those all the IDs, and then it give you the internal IP with your DNS, which is comes into a URI, and that URI is actually communicated through the internet over to another SIP server, and that SIP server is actually converted, and you can see various kind of technologies involved, transport layer. So you can see layer 2 technology is also engaged into one side is a LAN, which is wired, and on the other hand is the wireless. So you can see that is actually regardless of whatever the transport layer or your wire or not wire or physical infrastructure that you have, SIP doesn't care. SIP is just said as if I have a communication, I can do the communication in a real time, and as soon as the signaling is happen, then you can see this is actually it open up, which we call the media real time transport. So that way, that is actually the voice which we actually discuss here. Your media pathway, the voice pathway open up. So this is very important to understand from this point of view. That is actually once the signaling is done, everything is ready to go, then the media open. So that's the another need to understand. Now there are a lot of engagement of the SIP session protocol. So there are a lot of issues that involve, like a lot of the time that's actually the product as the new product is involving. Now you are into internet, and in the internet now you are actually with the cloud-based system. So this is where the security is the big challenges for all of a environment, and most of the time that's actually when we deploy these solutions. Those solutions like my PBX is sitting into into a cloud base like AWS cloud or Azure, or my cloud is actually Oracle based cloud, and this is where my 3CX is sitting, or my the Cisco call manager is sitting here. So how do I actually come here? So this is where this is actually make it more complex system. When I'm coming, how do I make sure this is actually I am the one that is actually this is the communication coming out, or it is something that is actually the threat from phishing, or is a DDoS attack, or it is like a call tampering, or maybe is a take off a vomit or spit. So this kind of the thing. So that's where the authentication is we make it sure this is actually this authentication is the process that is actually make sure that's the legit kind of a system. And now is actually once the system is legit, the authentication, then we wanted to encrypt the communication. So sometimes the communication is need to be encrypted because maybe it's the very high profile call and you don't want it to someone come and is actually listening your call, being in a middle attack kind of a thing. So you wanted to make sure that is okay, your call is also encrypted. And once the call is encrypted, so you need to, the encryption process need to be done by the SHA or the hash algorithm. Sometimes it's actually, some are the companies, this is actually what they do. They put the more I mean, if you are working with the DoD, the Department of Defense, so this is where is actually the call profile is actually, especially into all the defense related projects, that is actually they go with the highly encrypted and the public key and the private key kind of a concept, where that's making sure that okay, this is kind of a system that we actually make it sure that is okay. You are. If you give me your key, I can provide you my key. So my key is available. So now you have to provide me. So this kind of a public key and private key deployment, that's where we actually, once you provided a right kind of answer, then yes, you can have a call session. Another kind of the system which is getting very commonly used these days is TLS. TLS encryption is also very good. The older version is SSL. So in the TLS is actually is a web-based kind of the thing. So from a client to the another client. So that's the encryption that is actually you are doing it. So it's actually, as you can say, is the from endpoint to the another side of equipment. It is kind of TLS encryption is playing a role, and is the, as I say earlier, that is actually it is the improved version of SSL. TLS is a newer version. So TLS we have a 1.1, 1.2. So that's the most important thing when we are deploying the SIP environment. So we see the security challenge. We understand that is okay. Voice over IP has a security challenge. How to face those challenges, how to counter those challenges. So we have a couple of technologies which is right now in place: authentication, encryption, public key, private key, and TLS. And then once we are deploying these kind of technologies, so we make sure that is okay, our endpoint or our devices, which is a user agent or SIP devices, they do understand and they should actually understand these kind of a protocol. If it's not, then most of the time that is actually the call will be failure, and then you can get the response. As I mentioned earlier, the response you will get it into a 3-digit code, which is you can see here. So 3-digit code may say that's okay, 487 call failure. So that is frustrated, and this is actually is kind of a something that is actually when we do the deployment, it is most important thing that is actually we do understand what kind of a product that we are working on it, or is this product can do these kind of authentication, or it doesn't do it. If we don't do it, then definitely is the second most important thing is actually, as you can see, is actually our one of the SIP app is actually onto a phone. The phone may be, as we discussed before, the phone can be in any media. Your phone can be a LAN, can be a Wi-Fi, can be on the cellular network. So this is when the media is coming up. So now you are with the SIP environment. So you can see that is actually in this the communication. So now the SIP, you have running a SIP communication. So this is kind of a problem that is actually the SIP is a signaling protocol, and now the SIP is accommodate when does the signaling, it does accommodate the media. So this is where this kind of a challenges we come up when the SIP is actually initiated on the wireless, cellular network, and anywhere. So this is our one of a app, which is NSP80 SIP Intercom. Is free to download. You can download it and you can register with the SIP environment. You can play around it and you can do with the SIP cellular tower, or you can do the Wi-Fi. The only challenges that is actually is not the app itself, but the SIP timers. So SIP timers is actually most of the time T1, T2, T4. So is actually it is built inside of a SIP protocol. That is actually if I'm looking for a T1, that is actually so it give me it's understand, hey, you know what kind of a media I'm just over it, and then is actually give itself a time. Okay, go ready. Okay, I'm onto a T1 timer. So it's actually T1 timer is the something that is actually my round trip. So for example, if my round trip is actually more than 5 seconds or maybe greater than the 3 minutes, so that way is actually my session is not go and expired, and that is actually not affect my call flow. So this is where the the SIP also make a consideration on those challenges. So it's because of it's a signaling protocol, so that's why is actually these are the also a consideration for the SIP timers. This is a very important kind of a the tool. Most of a people who use the SIP, so they knew it how to understand the SIP call. So this is the SIP-P. SIP-P is actually is very XML based. So as soon as is actually you put the ID number, or you put each environment has a different kind of a deployment, but this one is actually give you the kind of a tool to understand from a one call to another call, how's my legs from one point to another point. And if you are actually see the whole flow of a the SIP environment, you can see that actually I'm sending a request, I'm getting a responses. So this one is give you a very good idea about the troubleshooting. That's okay, this is very graphical, and then you can see how the responses is coming in, how much a timer is actually is, and how much a round trip is actually is the coming up, and it give you the call rate, what kind of a port is connected, total time for spending on this call, total call, and the what kind of a remote host is connected, and it give me the very nice kind of a the idea. And this tool is a very highly used. Whoever is actually on the SIP side, they know that is okay, this is a trouble, this is a one of the tool that we use it to understand. Another tool that is actually we use for a SIP is the Wireshark. So Wireshark is actually not only give you the SIP idea, that's okay which protocol I'm using it, it also can capture your audio call, and then you can listen the audio call on which protocol, on which port, and on which session. As I told previously, the each SIP, it is actually invoke these sessions. So for example, if you wanted to send the ring bell, so that's also a one session. So that's actually engaged in one session, and somehow you don't getting, or you're not engaging the ring bell, or you're not engaging the ringtone or anything. So you can easily go with the Wireshark or SIP-P, both of a side by side. You can work together, and then you can see that okay on which port or which session that is actually is not communicated, and what kind of a message I'm getting it, and then you can understand that okay, yeah, this is where the issue is, and then we can easily identify the this kind of a issue at the application level. This is the most commonly, TCP and UDP. So these are the two transport layer protocol that we use it. And the TCP is actually you can run the SIP signaling on TCP, or you can run the UDP. Most of the time, this is actually is the transport is actually if is coming with the TCP. So all the packets that we're talking about it is in the order condition. So they are actually punching 1, 2, 3, 4, 5, 6, 7, 8. So it's make sure, and if one is missing into a TCP protocol, then what it does is actually it send the request again, send me back, and once it's received the sixes, and then he says, okay, I send you acknowledge. So this is the TCP nature. As compared to UDP, UDP doesn't detect 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and if 6 is missing, it doesn't care. It says, okay, whatever it is. It is bad, it looks bad, but it's good for a voice, because if you actually using a TCP protocol into a voice engagement, so what happens is actually if you are talking or you are actually yourself into a conference call with the SIP protocol and you engage the TCP and somehow the bandwidth is actually reduced. So what happened is actually now the TCP by the nature is resending the packet, and now you are hearing yourself the echo, and you say that, okay, why the echo is coming in, and you troubleshooting all the your hardware equipment, but it's still you not resolve it. The resolvement is actually because you choose the TCP, and that time on this conference is a lot of the people chewing the bandwidth, and that bandwidth is actually left nowhere, and because of it, the signaling protocol, the transmission protocol that you use it is the TCP, and that's by the nature of a TCP. That's actually if I miss any sequence, I resend it back, and when you send it back, so you can hear back, okay, why? Oh, that's the reason. Unlike the UDP. UDP doesn't care about it. The sequence is in order or out of order. It doesn't retransmit when the packet is lost. So that's why it is the excellent choice whenever you do the voice over IP. UDP should be the way of a transmission protocol. So that's why UDP is all kind of a protocol for voice over IP call than the TCP itself. So you can see this is actually in this diagram when the SIP signaling is actually communicated. So is actually send the SDP. So SDP is the session data protocol, which actually sharing the what kind of a bandwidth, how much is it, and then once is actually negotiated each other, then the stream is actually open up from sender side to receiver side, and then when the stream is open, then you have the RTCP stream. So RTCP stream is actually as a sequence, which actually very important from how the streams of audio is actually in place sequence by sequence, and especially if you are wanted to improve the quality. So based on the RTCP, you can engage or ingest the quality of services. And this is one of a scenario of a call service. So you can see that is actually you can do the RTP, which is like a real-time protocol, which actually with the sequence of this one, our best practice is actually if as I told you that UDP is for the media is the best practice. TCP may cause the performance issue, so that's where we actually recommend it. And most of the time on the SDP side, that is actually we are looking into it. That's when it on the WAN or internet is a couple of a G711 or G729 codec that is actually used for compressed or uncompressed voice. So we say that okay, don't use the G729 if you are using a DTMF tone. So that DTMF tone is actually may not be it caused the issue when you punch the number. So G729 is actually if you are using the DTMF tone, so just avoid it, just use the G711. How the DTMF tone as we are explaining it, so that's actually is when you are making a call and when you engage the call, so the voice channel is engaged. Now you want to send or select the zone. So for example, you want to go to a zone 1, zone 2, zone 3. So that's actually is the DTMF tone. So you're creating another tone. That's actually, yeah, I wanted to go for a numeric kind of a number. That's actually you want to press the number. So this is where the DTMF tone is actually very important, and that's how we actually handling of a DTMF. So DTMF can be in an in band or your selection of a RFC 2833, or is a SIP info. So these are the DTMF, kind of a, the flavors that is actually you requiring. Most of a common RFC, most of a common DTMF tone is the RFC 2833 or 2833, which is most common, and all the devices, they are compatible with that one. So this is another scenario that is actually where when the sender is actually created the RTP scenario, and then the receiver wants to receive it. So they actually sending the RTCP, which is actually a sequence number, and that's where we actually understand how the quality of this RTP is, and if there is a sequence number for any RTCP is decreasing or increasing, so we can put the QoS on it. So that's actually give us the idea of it. The SIP trunking is the another kind of a topic that we have. This is actually most of the time as we are seeing ISDN, and as we see in the first slide into our presentation, where we actually putting the circuit, physical circuit, that's actually make it the PSTN call. So SIP trunking is the very robust kind of a connectivity, a backbone connectivity, which actually give us talking to a real world for the provide outbound and inbound call, and is the give us a feature for the cloud. So is actually lower our cost, and plus scalability, cloud-based, and it is actually modify our legacy phone system, which is now available onto a cloud-based system. So trunking is kind of a connectivity that is actually make it your system not only talking inside of your environment, but now you can talk to the other provider and other companies, and so this is one of a feature for SIP trunking. These are the examples how we are actually so far in a SIP environment. So you can see that's actually our product line into N1000, which is mostly voice over IP, and then we actually communicating with the SIP environment. So you can see that's actually with this one, with the SIP gateway, we interchange from a SIP phone to the N1000, so both will coexist, communicated back and forth with the SIP gateway. So voice over IP with the SIP signaling. This is our equipment, which is NSP80MS, NSP80VS, NSP80AS, a door station, intercom, and plus the master station, which may connect with the SIP server, or you can do the peer-to-peer. If you are a SIP server, then we have a very nice kind of SP11, which actually can communicate easily. Modular structure can go into our M9000, and that M9000 can broaden up your the analog amplifier, which actually feed your 70-volt system to the entire zones. So this is also one of the features. And then if you have an intercom system side by side, which is N1000, so you can come at the N1000 SIP gateway. So you can see in this one picture, we are giving a complete solution to intercom as well as paging system. This is one of our product, which is SP11. So in this one, we give you another kind of option that is actually not only the SIP environment, that is actually NSP80 and SP11, but if you have other SIP system that is actually coexist with your SIP environment, so yes, our system can work without any compatibility or any issue. So that works very well, and our system can work into a peer-to-peer mode or with the SIP environment. This is actually one of example where this is actually you have the door station like a warehouse system. This is actually you have a couple of door station. If someone is coming in and he wanted to make a call over a SIP, so this is a peer, or you can do the master station. So door station is making a call if one is not available, so it easily can transfer to another wall. So this is like a one of a SIP environment that is actually you can do it. This is also our product line. This is actually we are giving you, and these ones is all PoE, and that PoE is actually except for SP11, which is not PoE. That one is actually is the connected with the SIP. But our SIP board, which is actually you can do is an SP80 SIP board. Which is actually can give you the extension of your analog amplifier can connect, go in and give you the one zone, which actually make you as a SIP environment. We have a speaker box speaker SIP environment horn, the ceiling type of speaker, master station, and then we have a paging with the mic. Thank you so much for joining us.